So today let's go to start with the concept about piano arithmetic. Giuseppe piano. Okay, this sir is from Italy, Sardinia, Spinetta, in 1958. He born in Italia, Sardinia, and this is he creates an arithmetics that will be very useful for us because we was last day was talking about the reversible predicates. Do you remember that?
Yes.
Okay. And can you tell me what means that a predicate what can be reversible? Can you tell me what that means, that a predicate can be reversible?
That you give like an output and you getting the inputs to this predicate.
Yeah, so you give the output.
That you give an output and getting the input, for example. Like when you have the inverse predicate, you're giving the inverted list as an output and getting the input like the reverse list.
Yeah. You can use the same piece of code in both directions.
Yeah.
Both directions. From give the input and obtain the output, and with the same piece of code, exactly the same, give the output and get possible inputs. Okay? And do you remember what's the problem? Which predicates is one of the questions we have for the last day. Is this question? This is question number 3. Which characteristic makes a predicate not reversible? Can you tell me about that?
Yes, it's the operation is.
Okay, nice, perfect. Okay, last day we did another exercise and there are more elements, like for example, operator of greater than, this type of operators. I'm going to make a test in PROLOG. And this operator needs to have a value in the right. For example, if x greater than 5, is x greater than 5? What do you think will happen?
Error.
Arguments are not sufficiently instantiated. That means, okay, I don't know, probably say, okay, I have an error because this operator is greater than and need a value here. If, for example, say 3 is greater than 1, probably say yes, no problem, or major or equal, greater than or equal, or same with this operator. Happen the same with is. They need a value in both sides. Example, 1 and 5 happen exactly the same. You have here an error. So if you use this type of operator, the predicate will not be reversible. This one, or is, or any operator that works with number. Okay? Okay, today let's go to see a way to make arithmetic operations reversible, like something like, okay, I want to add two number 1, number 2, and a result, and to make possible something like, okay, something like the number 5 add n1 and 2, for example number 5, and probably say something similar to this one, something similar to, okay, n1 is, for example, 1, or the first will be 0, and n2 will be 5, and give more, n1 equal 1, n2 equal 4, and so on. Okay? Do you understand the situation? Is how to create arithmetic operation reversible. It's not possible to do in any other programming language, and it's not possible to do in PROLOG. But now we are going to create a way to do in PROLOG with arithmetic piano arithmetic. Okay. Who? Christian? Or Christian not connected? Mario? What happened with Mario?
No, I'm connecting, but
I'm here.
Okay. This is person from your country. Piano.
Yeah.
Do you know about him or not?
Yeah, it's a a teacher of math.
Is popular in Italy or not?
Yeah, I remember a theorem about him.
Yeah, me the same. I remember. I don't remember the theorem, but I remember he's famous for that.
Okay, let's go to work a little bit. Let's go to play a little bit with this idea. Okay, it's very simple and very suitable for PROLOG. Let's go to see how this works. So, the arithmetic only has a symbol. The symbol is 0. And if we want to represent another number, like number 1, we use the operator is next. It's like, sorry, next. You can, S is from the Spanish, the siguiente, but let's go to write like in English. Like next. It's like N means and one symbol 0, one operator means next is N, then whatever, okay, and whatever. Okay. If you want, you can do at the same time with me.
Sure.
Okay.
I do it.
So, piano arithmetic, one symbol, one operator. Okay, let's go to define the operation using induction. Let's go to create the operator add. Okay? Add. Let's go to define this operator or this predicate. Okay. Have two numbers, and the important here is we can put that means that will be an input, or will be an input or an output. Okay, and it is true if R unify with the addition of number 1 and number 2. Okay? This is the explanation about this predicate. It's very simple. It's only add two numbers. Let's go to apply induction. Let's go to apply induction to resolve that. Induction tell us, okay, induction say the property have to be true for the first one, and second part, if the property is true for n-1, that means that will be true for n. Okay? In PROLOG, remember, you write something like that, and n2 is n-1, and property n2. Okay? It's a schematic way. Okay? This is the induction. Mathematic induction. Okay? Okay, let's go to apply this idea to add numbers with this arithmetics. Okay? Now, we don't have number 1 or number 2, number 4. We have things like this. If I want to represent number 1, I write that instead of the symbol. Okay? If I want to express number 2, I write that instead of the symbol 2, and so on. Number 3, I have to write this 1, 2, 3, 1, 2, 3. Okay? So, let's go to add numbers in piano. So, I have to give a solution for the first one. So, here we have, sorry, and here we have two variables. Do you remember what we do when we have two variables? Who can tell me what happened when we have two variables in input and we want to build the induction?
One stays the same.
Exactly. What happened? What happened with the rest? Are you there or not?
Yes.
Jeffrey?
Yes,
Yes, I'm typing, but yeah, I'm typing it.
Okay. Gabriela?
Hola.
Okay. Okay, let's go to continue. If you don't understand, I can repeat later, okay? Okay, let's go to add two numbers. So, it's exactly the same example, the same trick we use with append, with my append predicate. We are to build the induction only with one variable, and the other variable will remain exactly the same. So, for example, the first one is 0, second variable is number 2, for example. What is the result?
N2.
Perfect. Okay? It's okay for everyone?
No, can you repeat?
Okay, let's go to add two numbers. In piano, remember, using this arithmetic, this representation of number. Okay, we have we are going to apply the induction. We have two variables in input, n1 and n2, two variables in input, and one output. Okay? And when we have two variables in input, the trick here is build the induction only with one variable. The other variable remains exactly the same. So, instead of write 0 and 0, we only write 0 in variable n1, for example. What will happen? There something that will be wrong. For example, if we decide to use n1, will happen that the resolution of the problem will be very hard to resolve, very difficult to resolve. In this case, we will try to use the induction with the other variables. But if the induction works fine with the only with the first one, let's go to use the first one, okay? If something is wrong, if something doesn't work with this variable, we can use the other to build the induction, okay? Let's go to start with the first one. So, if we want to add 0 with another number, the result is, what is the result? If we want to add number 0 with another number, what is the result?
Two.
And 2, no? Agnes, who asked?
I don't know.
You don't know what is the result?
No.
You don't know?
No.
Okay. Think about add 0 plus number 2, number 1. Here you have the result. What is the result? 0.
2. Why 0?
0 plus 1. What is the result? What is the result? 0 plus 1.
1.
1. Okay. What is the result to add 0 plus 5?
5.
5. What is the result of add 0 plus whatever?
Whatever.
Okay. So, here, what is the result?
And 2.
Perfect.
Mm.
Okay?
Yes.
Nice. Okay. Second part. Let's go to build the induction. Okay? We have number 1, number 2, line 2. Sorry. 1 and 2. Okay? Let's go to build the second part of induction. Let's go to create this rule, but using piano arithmetic. So add a number. Number 1, number 2, Here I have to add to the n1 minus 1 and n2. Here we will have a result. How I can delete 1 here using piano arithmetic? How I can delete 1?
You put n3 and you write n3 is n1 minus 1.
Error. It's not. Think about that. How we change from 2 to 1 in piano arithmetic?
N minus 1?
No. How we change from that to that?
You write n1 minus n0 bracket 0.
What we do from 3 to number 2? So what is the difference between number 3 and number 2?
N from n.
We have to delete 1n.
Yes.
Yes.
Okay? Everyone agree with that?
Yes.
Yes.
We have to delete 1n. Here, from 1 to 0, we have to delete the n and the parentheses here. Okay?
Okay.
Okay, so we have a trick here. Instead of write only the number, what happens if I write here that?
Okay. Yeah.
How I can delete one here?
Mm,
How?
just and one, no?
Yes, perfect. Perfect. That is. Here is n minus 1 because here I put s and here I delete one s. This is 1 minus this number.
What does the S stand?
Sorry?
But and the next, not S the siguiente.
Sorry. And next, yes. I'm sorry because I did the exercise of the day. I always write in Spanish with S next. Okay? It's okay?
Yes.
Okay, perfect. If that is true, what we have here?
R.
Okay, and what is R?
N2.
N1 plus N2.
Exactly. R is the addition is N1 plus N2. Yes or not?
Yes.
Yes.
Okay,
Yes.
perfect. And if that is true, that will be true.
Yes.
Okay, but I have to make a modification here.
SR.
What?
NR. NR.
N.
Bracket R. Sorry.
It's okay?
Yes.
Yes.
Everyone see that or not?
Yes.
Yes. Michael, what do you think? Repeat? I can repeat? Repeat again?
Yeah, please. I didn't
Okay,
get this
okay,
one.
let's go to repeat again. Let's go to repeat again. It's very simple, and this is the part probably more difficult for people from computer science because it's extremely stupid idea. Extremely stupid. It's so stupid that people from in computer science we love to do very complicated things, and it's very hard for us see that something is so stupid idea. Okay, so okay, let's go to start again. Let's go to make this part. Second rule. I want one number, two number, the result for the n. I have to add to the n minus 1. Here, and this number is exactly the same. Here the result. How we delete 1 here? How we can delete here using piano arithmetic?
With the next, like, yeah.
Here, we write next, perfect, and here only n1. No? This is the way using piano arithmetic to delete numbers. To delete 1, sorry, to delete 1. It's the way is remove one n. One n and the parenthesis 2. Okay?
Yeah, makes sense, yeah.
Okay, perfect. So, if that is true, what we have here?
The result of n1 and n2.
Okay, we have here a number in piano arithmetics representation that represents n1 plus n2. It's okay?
Yeah.
Okay, and if that is true, induction tell us, okay, if that is true, that will be true. But we have to make a change here in the output. What is the change? What is the relationship between this R and this R? What is the relationship between that and that?
You have to add the next result.
Then next. Yeah.
Only one minus here. Only one minus.
Ah, okay.
We have to add one to this error result. Or we can add one.
Same with n.
Okay? Okay?
Yeah.
Extremely simple. It's a stupid idea. Okay? Okay, let's go to check if that works. Let's go to check. File, consult. Okay, no errors. Listing.
Yeah.
Add. Okay, let's go to add numbers. Sorry. Listing. Add. Perfect. Perfect. This is N0 here, induction, 1 minus here, the result, and one more here. Okay? Let's go to add numbers. Add number 0 and number 1. What I have to write here? Number 1 is I have to write in this way. I can't write this. This symbol doesn't exist in piano. This is the number 1. What is the result?
1.
1. Let's go to add 1 plus 1. What is the result? Number 2. Let's go to make a reverse use of this predicate. Okay, give me number 1 and number 2 that the result is number 3. Okay, this is number 3 and give me the result or give me the input to obtain this result and PROLOG say, okay, this is the first result, 0 and 3, 1 and 2, and 2 and 1, and 3 and 0. No more.
Yes.
Can you once switch to the Notepad?
Yes.
To the code?
You want the code? Okay.
Yeah, because.
Okay.
Thank you.
No problem. Sorry because I didn't upload. I didn't upload to the repository.
Yeah, no problem.
I will try to do when the class finish. Okay.
It's possible to do this with negative.
No, it's not possible because of the definition of piano. Piano is not. It's only works only for numbers 0 and greater than 0.
Okay.
It's only a piano starts in 0. If you think about what means negative numbers, it's like an convention, an illusion for us. It's something stupid. It's like, okay, I have -1. What means you have -1 car? You have -1 Ferrari. What means that? What means that? It's something. It's something stupid, no? I have a -1 Ferrari, -1 Porsche, or -1 airplane, or -3. I have -3 Ferraris. It's like an illusion for us, but it's not. It's like a convention. It's possible to create the same with this idea, but we have to create that. But we don't have at this moment. It's possible to create that. Okay. but we have to build. Let's go to make the subtraction. Let's go to subtract. Subtract and 1, 2. Let's go to make subtraction of numbers.
So stupid.
Why do we need to do these question marks again?
Sorry?
Why do we need to type those question marks again in front of the n?
Why I write that?
Yes.
Because this is that symbol in PROLOG means it's like if we search for PROLOG documentation in PROLOG, you can find predicates about, for example, list. Manipulation. In PROLOG, when you search for information about one predicate, you can find things like that. Member means this element is included in this list, and this means it's possible to give this value and obtain. You need here. Let's go to check here. Member is, for example, is element 1 in list 1, 2, 3, 4, 5, and people say yes, it's true, but it's possible to do give me elements that are inside this list. It's like it's optional value. That means it's an optional value. You can put or not. It's not required value. Okay? That means this question mark.
Okay.
For example, here we have a number plus. That means it's mandatory to have this value. If I don't write this, a value, the predicate doesn't work. And sometimes you will find plus, minus. That means this has to be a free variable, an empty variable without any value inside. So that means this is the meaning of this question mark. Here you can say, okay, give me members of, say, it's number 1, number 2, number 3, or I can say, give me a list with the number 1 inside, and probably say, for example, this one, or this one, or this one, and so on. This is a list that have 1 inside, and whatever other list. Okay?
Okay.
Perfect. Continue. So that means I can put this value or not, this value or not, or this value or not. So it is true if R is the subtraction of, for example, n1 minus minus. Sorry, 1 second. Want to Yes, minus. Minus. Okay, I'm sorry. Minus. Okay, so we're going to delete this number. Let's going to subtract this number. Okay, so subtract. Let's go to apply induction. Here we have a problem because if we have to delete something to this number, so this number has to be greater than this one. So I think it's better to put here number 1 and here 0 and build the induction now with the second variable. Okay?
Okay.
It's easier here to build the induction for the second variable instead of the first variable. So what is the result?
N1.
N1, perfect. Second part, induction. The rule of induction. So here,
Can we have negative numbers?
it's the same question that before. What means negative numbers is a convention. It's not. It's something like it's not true. It's like something like you have a -1. I don't know. -1 Ferrari. What means that? If you have -1 Ferrari.
Usually I have it, but today not.
Yeah.
Yeah, something stupid, no? I have -3 Ferraris. Okay, very good. You have nothing. It's a convention. It's possible to build this convention in this arithmetic too. We can build something similar. Put a symbol before, and that means negative numbers, but not now. We don't have this convention now. We have to create the idea. Okay? It's the same as real numbers. What means 1.5? I have 1.5 Ferrari. What means that? What means you have
1.5 Ferrari.
you have 1.003 Ferraris. What means that? It's a convention. It's something you say, okay, let's go to do parts of whatever and take some parts. It's a convention. It's something you can build in your imagination. But it's something that is not true. You create this idea in your brain, but that is not true.
But induction is only working with natural numbers, isn't it?
No, it's not true. It's not true. You have to delete or remove things from the side of the problem. But you can use the same idea with other type of problems, not only with natural numbers. For example, trees are not natural numbers. You can use induction in trees. That is very common. And trees are not natural numbers. But you can apply the same idea of delete something. It's like we are using an extension of induction, because we think about the idea of induction in more general way, not only with numbers, because in trees we take binary trees, for example. We treat the left side of the tree and the right side of the tree. We are not deleting one, but we use the same idea of induction, but not deleting one. We instead remove a part of the problem and resolve this part. Okay?
Okay.
Okay. So here, let's go to build the rule. Here, second variable, we have the induction. So, what I have to do here? It's something like, okay, wherever.
Ja, moet ik hele dingen zeggen. Mijn man Tom.
Oh, moet je maar gewoon doen.
Ja, ze moet ontdooid worden.
So, number one, and I have to do.
Ja, nee. Ja, ik gaf je een zak. En die andere zak was Nico.
Hello. Okay. Hello. Okay. We have to delete one here. We are going to build the induction with the second variable now. So
you put S0.
here
N2. No.
and 2. What I have to write here?
No, at the other side you have to write N and 2. And here N2.
Next.
No, not here. No.
On
You
the
put it
right.
N2 here.
Here and 2.
N2. And at the other side N and 2.
No. Okay. Let's go. We have to build induction. Here is n-1.
Yes.
I have to delete something here.
Then
Yes, sir. Next N2.
And
I have to put that, and here I have n-1.
Yeah.
Yes or not?
Yes.
Because I only apply the induction. I am not thinking at this point. I am not thinking. I only applying this idea. I only applying that. I'm not thinking. I only know this is a 0. I have to apply induction, so I have to delete one here. That's all. How we delete one in piano? Oh my God! Who have the microphone open with this noise?
it's not me.
Oh my God! Jeffrey? Is Jeffrey? Gabriela.
Yes. Hello.
It's not me.
Who is? Who is doing this noise?
It's not me.
Okay, it's very difficult because
Also.
a lot of noise. Okay, let's go to try. So, here we are only applying induction. So induction tell us, okay, if n-1 is true, n will be true. So let's go to add to n-1. Here we have to add to n-1. How do we delete 1 here? Using this trick. Putting here n, and here is n-1. Okay?
Okay.
Okay, do you agree? It's extremely stupid, really. It's not. I'm not thinking. Only applying that. Okay. Okay. If that is true, what we have here?
So then we have to do the same with the R.
What we have here? I have to answer this question. What we have here in this error?
And 1 minus and
N2, exactly. N1 minus N2. Okay. If that is true, that will be true. But what is the relationship between that and that?
Like alpha minus 1, so we will be next.
What is the relationship? What is the relationship between that and that?
We need to add n.
I have to
Add n.
that is great than that or less than. What do you think?
Great.
That is greater than. Why?
Because the number will be higher and higher at the other side.
Yeah, this number is 1 minus, so this is one more that.
So it's NR.
I have to delete 1. How we can delete 1? This way. Okay?
Yeah.
So it's the other way around, more or less.
It's okay or not?
Yes.
Yes.
And
Okay.
do we have to control that N2 is always inferior than N1?
Sorry, can you repeat? Can you repeat?
Do we have to control that N2 is always inferior to N1?
We don't have to check.
Okay.
Here, definition say, okay, it's true if the subtraction on N1 minus N2.
But what happens if in N1 is 1 and N2 is 2?
Have to be great, because otherwise it doesn't work. So this number have to be greater than this one. Otherwise it will say no, it's not, it's false. Okay, let's go to check. Let's go to check what happened. So listing subtraction. Okay, this is the code. And 1, 0, and 1, 1 minus, and 1 minus here. Perfect. So let's go to subtract number 3, for example. 1, 2, 3 minus number 1. What's the result? Number 2. Okay, let's go to make reverse. Give me numbers that the result is 3. Give me numbers that the result of n1 minus n2 are 3. So will be, for example, 3, 0 will be 1. 3 minus 0 is 3. Give me more. 4 minus 1. 5 minus 2. And so on. It's magic. That's magic. It's like some incredible thing, no?
It's nice.
So a stupid idea can build so powerful program. Any question?
No.
I'm going to share the code if you want to test.
Yeah, it's
by yourself.
It's working.
Do you think it's possible to multiply numbers?
Sure, why not?
Let's go to multiply.
Yes.
Multiply number 1, number 2, result. What means multiply?
Time.
What means? What is multiply? 2 by 4. What means? What means? What means that? What means multiply? 2 by 4. It's possible to change multiply with multiply addition.
Yeah.
Yes.
What means is 4 is
It's to add 2 4 times.
exactly, or
4 plus 4.
Yes.
so it's possible to be multiply, but multiply addition. It's like add several times, no? Okay, let's go to be multiplication with piano. So that is true. For example, it is true if unify with multiplication of n1 You like this definition? Let's go to add this number of times. Okay?
It's multi.
So multiply induction. What do you think will be better number to build the induction? So, okay, let's go to live here. Let's go to live here. I'm gonna leave this exercise for you. Try to resolve by yourself. Okay? And to resolve that, use addition, please. You have to use this predicate to resolve that. So, I give you 5 minutes, 10 minutes. You think will be possible in 10 minutes to resolve? 5 minutes?
Hopefully.
Okay. Let's go to reconnect in 5 minutes and give me the result.
Okay.
Okay? See you. See you. Hello?
Hello.
Hello, how's it going? Do you have the answer?
Nice.
You share your sorry. Now, okay. Gabriela, perfect. And you have the result?
I do this, but I think
Okay, first part, perfect.
I didn't test.
Okay. First part is perfect. It's like we're going to addition on and multiply addition of n1 anytime. 0 times is 0. Perfect. Second part, we have to build the induction. It's perfect. This
I
okay.
do with and true
The problem
because
is with the R plus N1.
I can do this.
No, it's not possible to do that because plus is not. You can apply this operator with piano numbers. So
Okay.
you have to use the predicate add. You have in line 12 and 13. You have to use the predicate add. So here
Okay.
you have to say, okay, I am looking at line 35, okay? Line 35, you say, okay, if that is true, in line 35, the right side is true, what you have in R, if that is true, what you have here in R,
In R?
what you have in R,
N1 and 2 times.
exactly, perfect. You have any 2 times and 1. So what do you need to, if that is true, if the right side of the line 35 is true, the left, please delete this part, this part. Please, yeah, delete that. Okay, perfect. So if that is true, if the right side is true, the left side will be true.
Yeah.
Okay, so what you have to do to R to make the left side true? What do you need?
I need to add N1.
Exactly. Perfect. Do that, please. Use add to add N1 to R.
But how I do?
Okay, right after replace the dot by comma. And now
Add
N1 comma
with the R.
exactly a new variable.
Okay.
Perfect. Dot at the end. Dot.
And here I put R2.
Perfect. Okay, that's perfect.
Okay.
Nice. Please check if you have the Prolog.
I just have online, but I can't
Or
check.
share. Do you know how to share your code?
Yeah, but I check just with the program online. I didn't download the program.
Okay, so I'm gonna copy exactly the same. I'm gonna check it for you. Okay?
Yeah.
I'm gonna
It's
copy
better.
exactly the same. Let's go to share. I'm gonna share my screen.
Okay. How I disconnect my here.
Okay.
I can put here.
Okay. Let's go to modify the code to add your program. Multiply. Can you see my screen?
Yes.
Sorry,
Yes.
I'm going to. Okay. Can you see my screen? No? Multiply n1 0 0. Okay.
Okay.
Multiply n1 and 2 times. I need to delete one, so you write here and and now multiply and 1 and 2 and I only need add number 1 to R2.
Yes.
It's exactly the same, no?
Yes.
Okay, let's go to check what happened. I have a problem here. Okay, here the problem here is say okay, singleton variable. That means okay, you have a variables that only appear one time. So it's better to write that because
Why?
yeah, because that means whatever variable. That means this is a variable. Is a variable that will be whatever, because we are not use that any number multiplied by 0 is 0.
Yes.
Whatever I write here by 0 is 0.
I have this problem.
Okay, but this is not an error, it's only an warning. That means okay, pay attention about that, probably you have an error, but this is not an error, it's only an advice. Okay, listing.
It's working.
Listing, multiply. Do you have Michael? Do you have the? Did you find the solution or not?
Yeah, nearly the same, but I did it with N2, like that only.
Okay. Multiply. And the rest of the people. What happened with the rest of the people? Mario, Christian, Colleen.
Yes.
Did you find the solution or not?
I just have a question.
Yeah.
For the first line, can we just write mult n1 1 and then n1 instead of 0 to initialize?
Here, 56.
Yes. n1, then 1, n1. Like n1 multiplied.
Yeah. We don't have symbol 1, the first part. We don't.
Okay, and n0.
But we need a solution for the first one. Induction tell us we have to give a solution for the most little element.
Okay.
So I have to give a solution for 0. 0 is the first one.
Okay.
So I have a solution here for that. So probably the solution you are telling are included in this one, because here if we have 0 here is the same. So here the option N1 is included here. Okay, let's go to check what happened. Multiply number, for example, number 3, 1, 2, 3. Number 3 by 2. Result have to be 6, no?
Yes.
1, 2, 3, 4, 5, 6. Or give me, let's go to copy that. Give me things that the result is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, give me numbers n1 and n2 that the result is 6. For example, 1 and 6. 3 and 2. And that's all.
I crashed.
Yeah, because they are trying to find more solutions. There are no more, so they start to infinite loop looking for more solutions, but there are not more solutions. Only this one.
I get an error afterwards out of global stack.
Yeah. It's like it's a stack. Yeah, it's the problem with von Neumann architecture with have this problem, but you can do the reverse use of this multiplication. Okay, let's go to finish here. Or you want more? Any question? You have some question?
Not at the moment.
Can you go back one more time to the notebook?
Yeah.
Let's see. Okay. Thank you. Yeah, great.
Okay.
Yes. Thank you.
Okay, I think it's enough for today, no? What do you think?
Yes.
Yeah, it's I think for people from computer science, will be harder because of the simplicity of the resolution. That broke your brain in a certain way. It's like, oh my God, what's that? It's not possible. It's something like crazy, because our way to resolve the problems is people in computer science. We try to resolve the problem if putting the code working in our brain, like looping, or we imagine the program working on the evolution of this problem in the time, and that broke your brain, because it's very hard to resolve this problem if you try to imagine in your brain that's moving the evolution in time, or how this problem is changing on time. It's very, very difficult to imagine that. For me, it's nothing like impossible. So it's very hard for me to do that. So it's very hard to resolve a problem in this way. So you have to make the effort to try to don't do that. Only apply induction. Induction works. That is the final idea of that. Induction works. Let's go to apply that. That simple idea. That's all.
That's true, yeah. I'm also struggling with the
it's
the
crazy.
simple way you write it.
Yeah, it's so extremely stupid. It's an extremely stupid idea, but that works. It's simple, but I think it's like, okay, it's more simple, more powerful. It's something strange.
It needs some time to get used to the format, how you write it, or how you...
It's not possible to do that in any other programming language. It's not possible. You can do the same piece of code, do that. In PROLOG, it's not possible to using operator plus, operator minus. It's not possible.
Yeah.
You can do only with this extremely simple idea. Only one symbol and next. Operator next. Is so clever. I find that so clever, so smart. And you can try to implement the idea of real numbers. What is real numbers? What is real numbers? It's an illusion. You can create the same illusion with this idea. There are no problem with create this illusion of real numbers. Because what is a real number? Like parts, create parts, make a division of whatever. What means 0,001 Ferrari? I have 0,001 Ferrari. What do you have? I don't know exactly. What do you have when you have 0.005 or 001 Ferrari? Can you tell me what do you have?